Hi everybody, I promised Jamie in VN that I was gonna post a video on how to solve just the A circuit. So this circuit, I guess I am on Zoom, so this circuit comes from this one, but at t equals 0, we're assuming O at t equals 0 minus. So from minus infinity all the way to 0, this is the circuit that we need to solve. And notice that I kept the VC. A lot of people in class were asking what's up with this VC. This here is the same as, that is the question, right? So what is VC of 0 minus and what is IL of 0 minus? So for the 0 minus circuit, this it's like I'm putting the plus on the multimeter on that side and the minus on the bottom. And for IL, I am making IL go to the right side because this here, the IL is going to the right side. But once I drew this, I don't need to remember capacitors, inductors, use of T's or switches. So I am done with that original circuit. Sawyer, can you be quiet? Guess not. So let's I'm gonna go through how I solved this, because a lot of students in class were taking longer than I expected for the circuit. So there's 11 volts there. No, sorry, no. Go back. Remember we talked? Back. So there you go. So now there's the 1K in series with those 11 volts, but hopefully everybody sees that the 2K and the 3K are in parallel. So instead of 2K and 3K, I'm going to only draw one, and it's going to be 2 times 3 divided by 2 plus 3K, which is 2 times 3 is 6 divided by 5 is 1.2K. So this is the parallel of this resistor here and this resistor here. At this point, maybe you're going to say, well, obviously, I can see that they are in parallel, but you lose IL and VC. And you would be correct. I am losing both IL and VC in this case, but my plan is to use current division. And I'll get back to that. For now, for a second, wait until I find a current here. So actually, the current's going the other way. But this I will be 11 divided by 2.2K. Actually, it's going to be minus, but that's okay. And so 11 divided by 2.2 is 5. And this means minus 5 milliamps. And then I'm going to go back to the original circuit. So what happens here is this minus 5 milliamps is the current going through this main part of the circuit here. And it's minus 5. But then it splits in two. And it's like this. There's the 1K there in the 11 volts. And then there are two resistors, a 3K and a 2K. You're such a good boy, Sawyer. And then this here is minus 5, and it splits. Oh, I should put milli. It splits into the 3 and the 2. In current division, what happens is that the current is inversely proportional to the resistances, because the voltages need to be the same. So what happens is that this current IL, which is the I3 milliamps, I3 kilo ohms, is minus 2 milliamps. And if I wanted the I2, this I2 here would be minus 3 milliamps. Oh, it doesn't work. And so this IL here is the I3, I am done finding I of 0 minus. And now all that's left for me to do is to find the VC. And hopefully you see here, this is the I 2 kilo ohms, which is minus 3 milliamps. And the VC is this between this node here and the node, this node here. So this is my VC. So VC will be I2 times 2 kilo ohms, which is minus 6 volts. This is VC of 0 minus. So these are the two numbers I was looking for in class today, and I know a lot of people tried nodal and mesh. I feel like nodal and mesh would take much longer than this, but if you did do it, and it was faster than what I just did, and you got the right answers, or actually the same time that I just did, and you got the right answers, you're good to go. So this is for t equals 0 minus. Now in the next video I'm going to solve for t tending to infinity, also in steady state.